whatever the fluctuations are there, they are further, regulated, or you can say it is converted into pure DC. Okay, and then given to the load can be charging of your cell phone or your TV set or whatever electronics you are running. So that is the load here. So now this step by step, this rectifier, right? So that let us see. So let's say that you want, right, from 120, what we need is 15 volt, right? So you have to down convert that and then do the processing, for example. Uh, Here, what we will see is this is a full wave release rectifier, which is using a transformer. All of you have studied in the first year the transformer here, and you can step up or step down to the required voltage, the power you need, right? And this is with a center tape, as you can see. And this 2 diode does the job of rectification, that is this negative waveform, right? That is also inverted, and the output is all positive side of the waveform, 0 to positive voltage. And this is the center tape here. And what it does is that if this is your sine wave, that is positive, negative, right? This will be positive, negative, right? And then this dot, they are same polarity and positive, negative. So during positive negative cycle, the voltage developed here is of this polarity, which will forward bias this diode. And remember, when we are talking of high voltage, right? See, whatever the voltages are, the drop across diode, this you should be very much clear in your mind that this drop, this curve is always the same. Okay, this curve will not change, the drop across the diode. So it is conducting for, let's say this diode, it is silicon, and if it is conducting at 0.7 volt, it will conduct at 0.7 volt every time, whatever circuit you put in. If it is germanium and if it is conducting at 0.4 volt, then it will conduct at 4 volt. This is 0.71, it is conducting properly, then it will conduct, so whatever the voltage drop, when it is conducting, it will appear, okay, and it will conduct. So this curve will remain same, and the drop across this 2 terminal I am talking of, okay, when it is conducting is around 0.7 volt, and that is never going to change. This nature, as we say now, that one's nature will remain till death. So this, unless and until it is not destroyed, this is the nature of the diode. And the voltage across this terminal and this terminal, if you measure when it is conducting, is always for that diode, whatever in the data sheet, 0.71, 0.7, whatever it is conducting. So here, when the voltages are high, it is already conducting. This is the drop across the diode, I said. And for positive, negative, right? So this guy will be conducting. This is not conducting. Conducting means that it is short, this part, okay? And it has a voltage drop of 0.7 volt, let's say, right? So if here it is, let's say 50 volt, then after this 9.3 voltage will appear here. So whatever. So that's what. So just, so these are high voltages. And then when it is conducting, the direction, this arrow is the direction of the current. Okay. So the current will flow this way and it will pass through this R. And the output is across this 2 terminal. Okay. So now when it is conducting, only voltage will be only developed when the current is flowing through R. And the current will only flow through R for positive half cycle of when D1 is conducting for the positive half. Okay. So, but if the voltage is less than, so let's say this is your input voltage, this is your, right? So let's say this is the negative, this is your input, this one. Okay. So this is your input voltage, 1 cycle and so on, right? Then after it has reached 0.7 volt, the diode will start conducting, right? So after it has reached 0.7 volt, it will start, the current will start flowing. Okay. So now this is your input voltage and this is the voltage across, this is V0. So this line, the dark line is your V0. Okay, so then if the current is flowing, right? And your drop across the diode, so for maximum voltage, right? Your maximum, this output voltage will be just by difference of the diode drop, VD, when it is conducting. So this difference is VD. Okay. And yeah, so this is your maximum Vs, this is your V0, and that difference maximum. And for negative half, when it is minus and plus, this is minus plus, this is minus plus, and this is conducting. And the direction of the current is this. So the current is going to flow this way. Okay. So even if it is a negative half cycle, the current will always flow from this point to this point. Will always flow in this direction. Okay. And that's why you get when it is a negative cycle also, you get a positive half. For the negative cycle, you get is a positive half, because the current is flowing from this direction to this direction, and this is your output voltage. And this is the voltage input output versus time. And this is your input voltage versus output voltage. And your input is following output after 0.7 volt. Okay, so up to 0.7 volt, whatever your this input you are changing, this Vs, your output is still going to be 0 volt. Okay, because there is no current flowing. It is this is not conducting. It is not reverse bias. It is not conducting for 0 to 0.7 volt, and that's why I is 0 and the voltage developed here is 0. So V out will be 0 for up to 0.7 volt. And once it has crossed 0.7 volt, this will start conducting, and the voltage that is developed here, right? So almost this point and this point are same, just the drop here you consider. And that's your output will follow your input, but always less than 0.7 it will remain, that difference. Okay, so that is about that, and this is another version of the same circuit. Are you understanding now? Otherwise interrupt me in between.
Yes, ma'am.
Okay, very good. So this is the same version of this circuit, but the difference is that here there are 2 diodes, here there are 4 diodes. Here there is a center tape, here there is no center tape. So what is the advantage? So advantages comes with disadvantage. Now listen, this is a transformer with a center tape. Now this center tape, it is more expensive compared to two more additional diode that is here. Okay, so this is more expensive, this center tape, compared to the cost of this 2 diode. So this is cheaper. Okay, again, this needs space. It occupies huge, the volume is more. And you know, diode, they are little devices like a resistor, right? Little diodes, you have seen that. If you have not made it to the lab now, so we will show you that. So that you have never seen all this component. Have you seen resistor diode? You have never made it, right, to the institute?
Not in the institute, ma'am.
Not in the institute, right?
Yes, ma'am.
You are from day one at home only?
Yes, sir.
Oh, okay, no problem. So this time we will, tomorrow we will show you the lab and the components. So they are little in few mm, okay? So 3, 4, 5 mm size devices they are. And you make circuits, and we will show you from, make sure that you understand, and through video you will see. So, and then, so space, cost, okay. So, and then the weight and also space, it will need more, this will be more heavy because of the center tape. And then, so this is, this can be, you can have this in a little area compared to this, and it is cheaper. But the drawback is that now see this, there is no center tape, as you can see. So plus minus will appear plus minus here. And when it is forward, this is plus, you can see that as I had said, the trick, this is minus sign, this is plus sign. Okay, this is same for all the diode. This minus, this is, what is this? This triangle is which? Anode or cathode? And this line is what? Line is anode or cathode? जल्दी बोलो, आपने टाइम नहीं.
कैथोड.
हाँ, कैथोड से क्या एनोड? जल्दी बोलो.
Cathode.
Cathode. See, minus is cathode. See, I said the trick. This is like a minus sign, so this is the negative terminal. Okay, it is a negative terminal, or this is the trick to remember. And this is if this is negative, the other is positive. So this is positive. and positive is A, anode. Okay, A and then C for cathode. So positive is A, then negative is cathode, as you can understand. And now if this is plus, so forward bias, if you think of, then if when this is plus, this is what plus, and this is already minus, and this is plus. So this guy will be forward biased. Okay, and then it is connected this way, and this way. So this too will be forward biased because this is negative and this is negative, this is plus here. So this and this will be forward biased, and the direction of the current will be, the current will flow from here. This is already reverse biased when this is positive half. Okay, so this is already reverse biased. And it will get a path from here, and then this is conducting. So this is the whole path. Okay, when it is forward biased, and when it is reverse biased, then this is the direction of the current. So this, right? And here when it is negative half, then this is the direction of the current. Right, so this is the direction of the current. It will flow from where? Here, here, and here, and then like this way. Okay, so this is the direction. Yeah, the other two are reverse biased. But as you can see, for every positive or negative half, there are 2 voltage drops. So before it was just 0.7 volt, here it is 1.4 volt. So this difference is 2 VD. Because this is appearing, this difference is appearing where you are taking your output across this R, and whatever is conducting, right? So if this is conducting, the current is in this R, it is flowing this direction. And if these 2 diodes are, the current is flowing in this direction only. So it is the direction of the current in both positive and negative half, the direction of the flow of the current through this load R, that is your V0. It is always this way. Okay. So you are during negative cycle also, the direction of the current with the voltage output you are taking is of that positive. Here it is negative. This is, this is ground, and this is this terminal. So the direction of the current is same for positive and negative half, and that's why you get positive voltage. But the drop now is that this difference is 2 VD. Okay, do you understand?
Yes,
Can
ma'am.
you explain how 2 VD again?
Okay, see, just simple. So if I'm considering ideal diode model, okay, Abiju diode. You can have 3 diode. I can make 3 diode also. Okay, and I'm giving some input voltage here, and I'm taking output here. Okay, output across here, input I'm giving here. Okay, so let's say my input is 5 volt. 5 volt. Okay, I'm taking, if it is just 1 diode, forget these 2 are not there, then what will be my output if I see the other side? If it is 0.7 drop, then
4.3.
for positive half, if it is 0.7 drop, what will be my output for just 1 diode?
4.3.
4.3. Now think there are 2 diode, then
And again 0.7 drop.
the same thing, now dear.
So ma'am, in which terminal we are taking output?
See, your loop is this way. You see, you know KVL, right? Kirchhoff's voltage law.
Yes.
So your loop is this way. This is making your loop. This is making your whole loop. So this voltage plus this voltage plus this voltage plus this voltage is 0.
Okay.
So now you do. What is this? Right?
Ma'am, I am asking in between which 2 terminals we are taking output, means that DC type.
This. Let's say you have a resistor here. Yeah, resistor set. See, there is 1 diode, let's say. Then a resistor. Okay, and then another diode.
Yes.
And think that you are taking output here. તો આ તો એક લૂપ બન્યું ને અહીંયા એક
હા.
અહીંયા વોલ્ટેજ છે તો this is one loop ના
Yes, yes.
you are taking here but આ તો ગણાશે ને
Hmm.
so this voltage across this if you are taking whatever third હોય તો third drop પણ ગણાશે.
Okay, okay, ma'am. I got it. Thank you.
So the voltage here, it is this voltage minus this. હજી ત્રીજું હોય તો એનું minus. You can keep this R here also. If you keep here also, same current will flow. See, this voltage drop is always 0.7. અહીંયા 0.7 જ થશે when it is conducting. As I said, you know this, the nature will not change. આ તો આમ જ રહેશે conduct થાય એટલે એનું when it is conducting it will not be 1 2 3 4 5 6 7 8 9 10 volt. આ 100 volt થઈ જાય તો when it is conducting the voltage drop across the diode across two terminal diode is 0.7 only. આ 10 volt થશે ને આ 0.7 હોય આ 0.7 હોય તો it is 10 minus 1.4 here. If this is 5, then 5 here will be across R will be 5 minus 1.4. Shall I go?
Yes, yes, ma'am.
This will remain same only, that you should keep it very firm in your mind. Now this stage here. Filtering. So what we use here to filter capacitor. Okay. So here, as you can see, this is a simple circuit when it is, so you have a positive half and a negative half. Okay. So if you see where this is for, so whenever you have a diode and you have a sine wave, always sine wave means it can be, an AC signal which can be a triangular or a rectangular or a sine wave. You always divide that wave into two half, positive and negative. And whatever the number of diodes are, you start giving that way. You quantify your voltages. I will tell you when, how, and what. When we do this type of examples, you quantify. Okay, મારું કોઈ ના આપ્યું હોય input અને આવું VI આપ્યું હોય તો you say, okay, let's say it is 0 to 10 volt. Okay, it is sine minus 10 to plus 10, and then you think and you do, because in exam this right thinking is very critical. So here you divide into positive and negative half. So for positive half, okay, this is conducting. This is conducting for positive half. For negative half, it is not conducting. So let's say now you start with a positive half, and let's say that you are starting from 0 and your voltage is increasing. So this guy is conducting. Okay, so you can take as an ideal diode, if it is 0.7 volt, it is conducting from 0.7 volt. Okay. So once it is conducting, it is going to go and charge this capacitor. Remember, right now in this diagram, what is shown is your output across the capacitor. Okay, and then we will see across the R, what does it mean? What is the difference? Okay, so right now it is the capacitor. Only think this as an independent circuit, and we are doing is a filtering. What do you mean by filtering? Right, so after this, you will have something like this kind of waveform. So these are ripples, okay, we say. So it is fluctuating a bit from the maximum. So this is going to charge. And now, so let's say this is maximum is 5 volt. And this guy is conducting up to that, and it will charge. And this will be eventually, it will reach, let's say 5 volt. Let us take it as an ideal diode. So now this has charged to 5 volt. And then it is decreasing. So from 5, it is 4.9, and then it is becoming to 0. So let's say 4. So this is 5. Okay, and now this is 4.9. So from here only this will be reverse biased, right? Because this positive terminal is now less than. Do you understand? R5 થયું? Ideal diode છે. Are you getting me? So this is 5 volt maximum. This will charge to 5 volt or no capacitor?
Yes, ma'am.
Yes, sir.
Yes, ma'am.
So this will, once it is charged to 5 volt, and this is changing. So after 5, this will come to 4.8, 4. And then 3, 2, 1, 0. So let's say it is 4.8 or 4.5, 4.8, let us take, or 4.9. So then this is 5 volt, negative terminal is 5 volt, positive terminal is 4.9, 4.8. So this diode is going to be what? Reverse biased. So from this, after this peak, this diode will be reverse biased. So reverse biased means it is conducting or not conducting?
Not conducting.
Not conducting. So no current is flowing, and this where this is charged, and it will remain, this whatever it is charged, maximum it will remain. Okay, it will remain charged because it is not getting any path to discharge. અહીંયા કશું connection નથી. This is your output. If you measure, right, then it will remain 5 volt because there is no path for it to discharge. And a discharge થવું હોય તેને path જોઈએ કે અહીંયા, let's say if there is no resistor right now, but if there is a resistor, what do you mean by a resistor? I'll explain you shortly. So then it will get a path to discharge if there is a resistor there. Okay, any component other, any other conducting component. Okay, but it is not there, so it will remain. And then by the time it will remain 5 volt, by the time it is again it has reached the peak, and it will continue to be 5 volt. But in practical thing, see, now you are getting this DC, a DC thing, pure DC. Okay, but this has to be given to some circuit now. If my phone is, let's say 5 volt, I have to give to charge it. આપણે charge કરવા 5 volt DC આપીએ, right? So there is a load. The phone is your load. If you are giving an input to your PC is your load. Now that load will have some input impedance. Okay, એમાં RC બધું આવે. So now if there is a load which is represented by, let's say, just R, or you can have a C also in parallel or here. So R and C, but to keep the case simple, this DC is given to some circuit, some load. For example, your phone, your TV, your laptop, right? So that is represented by R. So now what will happen? So now this is a practical case. Okay, that this is your load. So our DC banu, you know now, this was your DC. But that DC is given to the load. And when it is given to the load, then what happens? So I am adding that load here. એટલું સમજાણું પહેલા?
Yes, ma'am.
Yes. So now it is like, a new member is coming and will change the way things are working. So new Bahu is coming and things change in the home. It is something like that. But you cannot stop this because this is, for this circuit only we have created DC. Okay. So now this is here. Now what happened? You have understood up to here. So I will start from here and I'll explain you the whole thing. Be attentive. So this thing you had understood that your capacitor, let's say at this point your capacitor had charged, right? Like here. Okay, take this. Okay. And then this went into, because this was charged maximum, this went into reverse bias from this point, right? I pointed out reverse bias.
Yes, ma'am.
So yeah, so from here the diode has reverse biased. Okay, so now what has happened? This capacitor is no more charging because ayathi charging hato. And then it is getting a way through this R to discharge. Now this is providing a path to discharge. And now this was reverse bias. This was like cut. It was cut from here, and the only resultant circuit is this. And this which was charged fully will start to discharge from here. Okay. So now by the time this is following this waveform for which this diode is reverse biased, this guy will start to discharge. So it is discharging. So let's say it was 5 volt and it has discharged to 4.5 volt. Okay. By the time that this has reached 5 volt. So let's say this is 0 to 5 volt and this has discharged to, so now it has discharged slowly. And now the voltage remaining is 4.5. So now let's say this is 4.5. So jab here, now when this has reached 4.5 and then immediately 4.6, 4.7, this diode will be forward biased or no? Because now this point is, this is 4.5 at some point here, let's say, and now this has reached 4.6. So if it is an ideal diode, it will start conducting, right?
Yes, ma'am.
Yes, and it will charge this capacitor fully again. So here, this is the point that your diode will start conducting from here. For all from here to here, it was, sorry, let me use another color. So from here to here, your diode was off. Okay, but at this point now it has started conducting and it will only conduct for this time from here to here, and again it will get into reverse biased. So is, as you can see, your diode, so if you take this is repetitive, right? So in one or two cycles this will charge fully. So when it is charged fully and then discharging, we are taking the cycles, and if you see it, the diode is conducting for this fraction of time only, for this time only. This is repetitive, so this time only. So this between T1 and T2, that is delta T, the diode is conducting, and this is the diode current. See, it is conducting for this much time, and this shows ID is the diode current that it is conducting. The diode is conducting for this much time only. And now, very important is that you should know that this is the time period of your wave, right? So from here to here is the T, capital T, one sine wave, pura circle, right? So 360. So this is time T. Okay, so what we will want is that we want pure DC, pure straight line. That is only possible if this RC is very, very greater than T. So provided this RC is very, very greater than T, otherwise this will discharge fully. This is like, then it is like following, your output will be following your input. This output will be following the input. Okay. So instead of, so you want is a straight line. So this discharging should be very slow, meaning that this RC should be very, very, this time constant should be very, very greater than around 10 times, at least greater than, then you will get almost DC, but with a ripple. So now you understood this much. Okay. So this dark line is your output. So this dark line is your output, this output that is appearing here. So this dark line is your output V0, and your output is your I0 or IL. This IL is output shown here. Okay, so that IL is following V0. So IL and V0 are of the same nature, but this is current. I is the current. So this is your IL, which is following your V0. And your diode is only on for a fraction of a time, and this is very important. Your CR, your RC should be very, very greater than the time period of this sine wave. This is the peak voltage, and what you get is this output, which is not a pure DC, but with ripple. That's what you get here, and we want to remove that, and we know the remedy. It is the Zener diode that you can use, okay, to remove that. And so this was for half wave, right? And so this is a half wave rectifier. If you make a full wave, then for the negative half also you will have a positive cycle, and you will get like this with this ripple. Okay, so this is your ripple, this much from this minimum to this maximum. This is your ripple voltage, and this dark line is your V0. This is for full wave, as you can understand. Okay, and then we use Zener diode to get pure DC, and we will see that also. But you have understood Zener, and now you know, and I will tip in into that also. So let me show you this first. So here, if I am talking of, then this I'll give you as a homework, that this I'll come later on. Let me take this first, okay? Then you will understand this better. So are you okay with this? What is this straight line? But this is not a practical circuit. There has to be a load and that R. And if R is there, it will start to discharge also. And we have to still remove. So there is a pending step, that is it will pass through the voltage regulator, that is Zener. And then this pure line will go to this. So now let us understand this circuits to understand these applications better. Okay, so this is known as clipping action, where to protect your circuit from overshoot or something, we will clip, because if the overshoot, if your circuit, even if your circuit, let's say this circuit at your this rectifier or from this point, if this, because of the fluctuation here in the AC mains, okay, if you are dropping down this to, let's say, from 120 volt, you are dropping down to, let's say, for example, 50 volt, all of this component, they are designed, if you give very high, if you give 100 voltage to your component, it will break down, right? It's like a bomb explosion, everything will be blown off. So like that way, so even if because of a fluctuation, if for some reason it goes high, then this all things will be blown up. We don't want to do that, we want to protect it, right? So for that also, there is a circuit that is known as clipping circuit, that if it goes below some voltage, it will cut it off. Okay, and the other thing, this clipping circuit, uh, clipping action, that is one thing to protect your circuit. The other is to generate the waveform of the required shape. Okay, so for some applications, you may need rectangular wave. When you are doing your simulation, also you can select and give a rectangular wave, a sine wave, a triangular wave. So how do you get those shapes? Okay, so that is also through, there is a circuit there, right, to which you are giving an input and generating these shapes. There is nothing that there is not a reservoir from where you will have a sine wave, or that also has to be generated using some circuit. So this kind of clipping circuits can generate, if this is sine wave, it will give you something like rectangular wave. Okay, you can shape it, and that's what. So one is for protection, one is to generate the wave form, particular size of waveforms, okay, shape of waveform. So for example, now let us try to understand this circuit. And I'm starting from a very simple one. And in the exam, what you will be asked is some RLC, and you will be asked to give the output voltage or the voltage across the diode, or like that way. So one is time with respect to voltage. Your voltage here will be input and output both with respect to time t. And other thing that you may be asked is to plot the transfer curve, where this is the input voltage. Okay, you are varying the input voltage, and then this is the output voltage. Okay, so this line is the output voltage. So that is the transfer curve. So for T versus V, you will be asked, or V0, or V in versus V out. Okay, so you will be shown where is V in, where is V out, and you have to plot it. So this is the transfer curve, and it can go in any direction. So these are the two things that either of things we will be asked, and you have to understand. This is R here, this is the diode, and it is connected this way. And let us start with the ideal diode first, and I am calling voluntarily. Whosoever will reply will leave the ID in the chat box. As said, you will be rewarded if you answer. So explain me this circuit, how it will work. You can unmute your mic and start to speak. This is R, this is your input voltage, and this is your output. Everything is shown. You have to explain me that if this is the input, how and why do you get this output? Chalo jaldi.
In positive cycle, it will be reverse bias, so upper cycles will be cancelled.
Okay. See, reverse biased, you are right. So this is positive, this is negative. Okay, and when you are talking of this cycle, let us do step by step. You take the positive half. So this is positive and this is negative, right? So this is positive, this is negative, this is positive, this is negative. So it is forward bias or reverse bias, first of all? Forward bias kone kehvaye?
Forward bias.
It is forward biased. Now, forward biased means what? Diode is conducting or not conducting? Ideal diode.
Conducting.
Ideal diode. Okay. So conducting means this is short. 0 વોલ્ટે કંડક્ટ થઈ ગયું બરાબર એટલે શોર્ટ થઈ ગયું હા કે ના
Yes, ma'am. Yes.
Yes, ma'am.
short means this point and this point are same
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
means same potential. So if I'm taking an output across this and this, the difference is what? 0.
0.
So for all of my positive half, what I get the output?
0 volt.
0 volt.
Very good. Now negative half. So negative ma a negative thase, a positive thase. And what is this? The diode is
Open circuit.
open
Non-conducting.
circuit. Current is flowing or not flowing?
Current cannot flow.
No flow. Last segment નથી એમ માનવાનું. Open means this segment is like not there. આ cut જ છે. So current will flow from here. Will current flow here? Through the R?
There is no path, so it will not flow.
See. This, અહીંયા કોઈ path નથી. The current is not flowing because this is not connected. This is open. So no current is flowing through R. So if you write a KVL, write all the voltage that is here. This is 0 drop. I is 0. So V is equal to IR. So I is 0, V is 0. So whatever the voltage is here will appear here or no?
Yes,
અહીંયા
ma'am.
જે voltage હશે એ appear થશે. So that's what. So whatever was here appeared here at the output. Clear ke nahi?
Yes, ma'am.
See, if you don't think this way, you are mistaken if you don't think this way. And this is the logical way of thinking. Similarly here, that if you change this, this is minus, this is plus, and it is only conducting when this is minus and this is plus. So that is this part. Agreed or no?
Yes, ma'am.
So it is conducting. It is conducting means for the negative half, this will be conducting means this is potential is what? 0. 0 thayo negative half ma. And positive half, it is open. A plus hoy, a minus hoy, so it is open. All the voltage will appear here. So this positive half, it will follow this output. Clear? Jaldi ha ke na ho?
Yes, ma'am.
Yes, ma'am.
Very good.
Yes.
So now, okay, good. So now this was ideal diode, but in this whole universe, nothing is ideal. Okay. And you can say everything is ideal also and nothing is ideal. So it depends on the definition. But practically, if you say this is ideal, right, then practical things are there. And practical is what? 0.7 drop when it is conducting. So now you have to think if this is the circuit. Okay. So let us... 1 minute. Okay. So let me take this only. Okay, with 0.7 drop. This I'll come later on. Let us take this with 0.7 drop. You understand me? Ideal or two. Now let us take 0.7 drop. So this is what? Positive. This is negative. Let's say I'm talking of positive half and then this is negative. I'm talking of this half cycle. Okay. You take the one when it is conducting, let's say. Okay. Not conducting. Okay. So when it is conducting, you take. So it is conducting for this polarity now. A polarity it will conduct for positiveness, positive half.
Yes,
This
ma'am.
polarity is correct, right? Now to make it conduct, this has to be plus minus, na? Plus plus or minus minus, it is forward biased. So for positive half, it will be forward biased. But now it is not reverse biased, but it is not conducting for 0 to 0.7 volt. Okay?
Yes,
A
ma'am.
0 volt say, let's say this is 2 volt. 2 volt. Okay, let us give some voltage if it is not given to you. 2 volt, so up to 0.7 volt, it is not conducting.
Yes, ma'am.
Yes, ma'am.
So now when it is conducting, you divide the voltage that if it is 0.7 drop, then you make or a milestone that you do from 0 to 0.7 and then 0.7 to 2 volt. Okay. So for 0 to 0.7, this is not conducting. It is not reverse biased, but it is not conducting. So if from here, if this is not conducting, okay, that means that no current is flowing for 0 to 0.7 volt. Reverse bias જેવું થયું ને?
Yes, ma'am.
Yes, ma'am.
હા, તો reverse bias જેવું થયું, and it is not conducting. So not conducting means this is like not there.
We follow the
Zero,
input.
either 0 to 0.7 નું શું થયું? It is following your output is following your input for 0 to 0.7. If I am drawing my input this way, અહીંયા ખાલી superimpose કરું છું, and I am showing you with the green line my output, then my output for 0 to 0.7, it will follow the input or no?
No.
Conduct nothing. See, forget other voltage. 0 to 0.7. So 0.1, 0.2, 0.3, 0.1 હશે તો શું થશે? Conduct કરશે કે નહીં કરે?
It will still be zero output.
I mean, that's what I'm explaining you. Be patient. You answer my question step by step.
No, no, ma'am. No, no.
0.1 conduct કરશે નહીં કરે.
Non-conduct. No, not
2.7 it will not conduct. You can think. But hello, hello, hello.
Hello.
Am I audible?
Yes.
Huh.
Yes, ma'am.
Huh. Up to 0.7, it is not conducting.
Yes, ma'am.
From 0.7, it will start conducting. So let's say 0.69, it is not conducting up to. Nonsense, somebody is just ringing. So this is, so you think this is open. The open is also the output will be what? It will follow the input. Yeah, 0.1 as the 0.1 house. Yeah, 0.2 as the 0.2 house. Yeah, 0.3 as the 0.3 house. Is that correct or no?
Yes,
Yes, ma'am. It is correct.
Yeah. So my so this green line, okay, that is my whole input. I am showing the range. So my output will follow my input up to 0.69. Have a 0.7 આવ્યું. So 0.7 and then 0.8, then 1 volt, 2 volt, all those voltage, and again 0.7 here. For all of this voltages, this is conducting or not conducting?
Conducting. Conducting.
Conducting. So when it is conducting, what will be the voltage drop?
0.7.
Across diode 0.7 જ રહેશે. I said you કે ભાઈ ડાયોડનું વોલ્ટેજ ડ્રોપ તો 0.7 જ રહેશે. અહીંયા તો ભલે ને જે વોલ્ટેજ વેરી થાય, what will in the circuit as a whole, if you are thinking what will change? See, diode is fixed, and nature fixed. It will not change irrespective of the voltage here. The voltage drop, even if it is 100 volt, the drop will be what? Still 0.7 volt only when it is conducting. I know nature share. Conducting 0.7. Even if it is 100 volt here. What will change is this I, depending on, this is fixed. This is, let's say 100 volt, then this is 100 minus 0.7 divided by R is your current flowing. If this is 10 volt, then 10 minus 0.7 divided by R is the current flowing. Okay. But that's what. So here, so this is 0.7 volt. So from 0.7, if you start to 1 volt, 2 volt, and again you come back, it is what? 0.7 volt. And then again same thing. And then this way. Okay. It will follow the input up to 0.69 and then 0.7, it is all 0. Or a 0.7, not 0, 0.7. For 2 volt also it is, if it is 1 volt here also, it is conducting, the voltage drop is 0.7. If it is 2 volt also, it is conducting, the voltage drop is, voltage hoy ke voltage hoy, right? It is 0.7 only, your output. This will remain fixed now when it is conducting.
Yes, ma'am.
Yes, ma'am.
Yeah, so that's why this is the thing. And here, when I'm talking of this one, then here it will follow for 0 up to 0.7 volt, then straight line, and then like this way, right? And then when you have this both placed, then you get this waveform. So intersection of both of them. So when you have this kind of thing and it is not an ideal diode, you 0.7 drop, then what you will do, you will take the positive half. So positive half is plus, minus, and this is plus, this is minus, this is minus, this is plus. So when it is positive half, this will be forward bias, and this is already open. Positive half. And then for the positive half also, it is not conducting up to 0.69. If it is conducting at 0.7, up to 0.69, it is not conducting, right? So it will follow, your output will follow your input, and then you will have this straight line and like this way. For the negative half, similarly, this is like not there, open, and you concentrate on this only, right? And then you have like this way the waveform. So this is for voltage drop of 0.7 volt. Okay, and if it is an ideal diode, you will have a straight line.
There are straight line at 0 volt, right, ma'am?
Pardon?
When both the diodes are ideal diodes, the output will be 0 volt, right?
Correct, correct. When it is ideal, let's say it is 0 volt. Why? Because this is positive, this is negative, this is negative, this is positive. For the positive half, when it is plus, and when it is minus here, right? A plus 10, a minus 10. So what will be, so this is open, so this is not there at all. Correct? You agree?
Yes, ma'am.
And for the positive half, this will be forward bias. Let's say this is D1. So D1 will be forward bias for the positive half. And the voltage drop in ideal is 0.
Yes.
So it is
yes,
forward bias. Voltage drop is 0 for the whole half circle. Right? And what you have is, this is changing from here to here, but this voltage and this voltage are same. So difference is 0. That's why you get 0 for the positive half. When you are taking a voltage, it is the difference between the two. In ideal diode, the difference is 0 when it is conducting.
Yes,
so at
ma'am.
0 volt, it is conducting. Difference of anode and cathode is 0. So your output is 0. Okay.
Yes, ma'am.
Now we'll little bit modify. So with that understanding, we'll go ahead and a little bit modify. And in this case, we are adding. Now see, this is fixed. This is the physics, and it comes with that, and you get that. But in your some design requirement or circuit requirement, you need a waveform that is from -1 to +1, or minus 1.5 to +1, or +2 to minus 0.5, right? Those kind of waveforms, you need it, some input that you want to give. Positive can be different voltage, negative also different or same, but whatever you want, not just 0.7. I mean, it can be 2 volt +2 to -2 or whatever, a rectangular wave or something like that, let's say. Then what you do, we will add this voltage, the supply, to this diode. Okay, so let's say that in this case, if you see, so here is the sine wave and this one diode only. So this is positive, this is negative, and the supply is added such that this is positive and this is negative. So when you talk of the voltage drop, they add up. When this is conducting and the voltage drop, if you consider is 0.7, then it will add up, right? Positive, negative will add up. But if this is reversed or this is reversed, either of them is reversed, then you minus, right? In when you have a voltage source, that is, you have positive terminal, negative terminal, and then again positive and again negative, then by superposition you add up. And if this is 2 volt and this is 3 volt, it will be 5 volt. But if this is 2 volt and this is 3 volt, but the terminals are minus and plus here, and this is plus and minus, and then minus are here connected, right? Then it will be minus 1 volt resultant. You know that. Okay. So when you are considering again, as I said, let's say this is some bias voltage and this is 0.7 drop. Then instead of just 0.7 drop, right, you will add that bias voltage also. If this is 1 volt, then this is 1.7. So this is plus, this is minus. Let's say this is 5 volt. Okay, peak to peak. And with an example, this is 1 volt. This is 0.7. Okay, when it is conducting drop, 0.7 volt, as you know. And this is 5 volt. So it will be forward. You start with when it is forward, the potential of this, it is forward bias, plus minus. So during positive half only, it will be forward biased. During negative half, this is reverse bias. So this when it is reverse bias, this is like not there at all. Okay. So for now, positive half, it will be forward bias. So this is plus, this is minus. Let me cut this. Yeah, so for the positive half, it is plus minus. Okay, and this is 1 volt here. So now this circuit will only work. This will be only shorted. Okay, when? So now let's say you start with 0 and then 0.1 volt. So either 0.1 volt here. So let's say 0.1 volt is here, let's say. Okay, and this is 1 volt. Right, so this positive has to be greater than this 1 volt, right? And then plus this bias 0.7. So if this is 1 volt and the drop here is, this will only conduct if this is 1.8. If this potential is 1.8 from this volt, 1.8 only, right? This will conduct. Again,
Yes.
Below 1.80 to 1.8, or let's say, sorry, 1.7. I mean, conduct is 1.8. It will not conduct up to 1.7. So 0 to 1.7, it will not conduct. It will not conduct means no current is flowing. No current is flowing means the voltage drop across here is 0. And whatever the voltage is will all appear here. So your output will follow the input up to 1.7. So this dark line is your output. And then when it is 1.8, this is forward bias. And the drop 1.8, if it is 2 volt, 3 volt, this is forward bias. And whatever the voltage, 5 volt, 3 volt, 2 volt, the drop across the diode is 0.7 and then plus 1 this. So that is 1.7. So whatever the input you are changing, your output is still 1.7 if V bias is 1 volt. And then once it gets lesser, this is once it is 1.7, then 1.6 and all negative, this is not conducting for this region, and that's why your output is following your input. And then otherwise this is also reverse bias. So not conducting reverse bias is the same thing, and your output will follow the input. And this is what you see. So this is the kind of the waveform that you will see. And similarly for this negative, right? So this is now, this is minus, this is plus, and this is I will teach you when the polarity is opposite also, but this is additive. Okay. And the way you saw here, this will be tripped. Okay. This will be tripped. And then when you have this back to back and they are still additive, plus, minus, this is plus, this is minus. Okay, so if this is 4 volt and this is 0.7, then it will be following up to 4.7 this, and then it will remain constant up to here. And once it is decreased 4.7, then it will follow this. So for all higher voltages, the output will remain constant to 4.7. And similarly, this will be added in the negative direction, and this is minus 6.7. So based on the same thing, okay? And if I go ahead and I show you this is Now you can understand this is Zener diode. The direction of the current of the Zener is in this direction. Okay. And then these are back-to-back connected Zener here. And for this input, which is shown here in blue, this is the output. And this will be my homework to you. That so here also you will divide into positive half and negative half. And you will explain me next time. Whosoever, I'll write down the ID and this Excel sheet we prepare as per your ID. Okay. So you will tell me and you will be rewarded for whatever answers you give, but I'm giving you this as a homework that this is V out shown here. For this kind of circuit, it does the same job. You can have two Zeners connected back to back, and you will explain me next time for this sine wave input, why is this output this way? Okay. Now, who will explain me this? So here, instead of a diode, you have a 5-volt Zener. So from the theory that you have learned, and this is V out here, it is shown, V in is shown, and V out is shown. So from all these basics and whatever you have studied so far, can anyone explain me now? This is homework, but now anyone can explain me this? Or you try, because it is all try only. It's not that the answer has to be correct, of course.
Ma'am, in the forward bias,
yes,
yes, this one. For the positive half of the cycle, up to the 5 volt, the Zener diode will be reverse bias, and
very
but
good.
after 5 volt, it will break.
Exactly, you are right. So see, now this is what, this is minus of this, and this is plus of this, but it works in what? Reverse bias region. So when will this be reverse biased? When this is plus and minus, as he said. What is your good name?
Yes, Mudit.
Huh?
Mudit,
very nice. So Mudit is correct. Zener, the characteristics of diode, you know. Okay. And Zener, so it is, this is same like the diode. Okay. So it will work in this region, and what it is meant to is as a voltage regulator, and it will work in this region. Okay. This is 5 volt, this Zener. So if this is reverse biased at 5 volt, right, it will conduct at 5 volt. Okay. So for positive half, it will be reverse biased. And then this is your 10 volt, let's say, right? Yes, please. So now we are talking of this region, and for positive half of the cycle that we are having from 0 to 10 volt, and then again 0, it is going to conduct at 5 volts. At this 5 volt, it will conduct. Below 5 volt, you know that the current is in nanopicoampere, and we say it is off, it is not conducting. Yes, please. So Mohit, say agar.
Yes. Then for the negative side, for the other half of the cycle.
No, listen. So 0 to 5 volt first. Up to 0 to 5 volt, what will happen? It is conducting or not conducting?
Non-conducting.
It is not conducting.
Because it is reverse bias and its breakdown voltage is 5 volt. So
yes, so it is not conducting in reverse bias up to 5 volt, and that means no current is flowing. Correct or no?
Yes.
So here, so no current is flowing here, right? And if you write down the loop equation, here is your V out. So through R, 0 to 5 volt, up to 0 to, let's say 5 volt is here. So up to 0 to 5 volt, there is no current flowing, and your output is what? I is 0. So V is equal to IR. So output, so up to 5 volt, your V out is 0. This is 5 volt here, right? So up to that, your output is 0. Correct or no?
Yes.
Yes, ma'am. Yes.
Yeah. And then after 5 volt, whatever, 5, 6, 7, 8, 9, as we had seen in the Zener here before, right? The same thing. Here. This one. Right? As we had seen there. whatever, up to, so this is maximum is 10 volt, right? This will conduct for 5 volt only. So this will be, so when it is, so so this drop is fixed 5 volt. Okay, so now if this is 6 volt, I have 6 volt as much as 7, 8, right? So 5, then 6, 7, 8, 9, 10 volt. So Mohit, you write down your ID, okay? So 6, 7, 8, 9, 10. This is 5 volt. So you're here, when it is 6 volt here, it will be 1 volt. Okay. Yeah, 6 volt has the output will be 1 volt. Yeah, 7 has so for pick 10 volt and 5 volt, your maximum will be 5 volt. Right? So minus, so 10 minus 5, so 5 volt here, KVL, right? So that is that. So it is following, but it is 5, up to 5, it is 0. And after that, it is following your input, but it is always 5 volt less, because that's the drop here. Yes, and tell me, Mohit, after for the negative half.
Ma'am, my name is Mudit.
Mohit.
Yes. For the negative cycle, the diode will be forward biased, so it will pass all the values of current.
Very good, right? 0.7 drop little na kariye na, it will start, it is working. So it is, the voltage drop is almost 0, you can say, because this is bigger volt, 0.2, 0.3, that is okay. So almost that. So આને થોડુંક વધારે થોડુંક નાનું નથી કરતા એમ, right? Otherwise little bit, and then it will be, to be more precise, 0.45 volt, થોડું નીચું હશે. But we are just following that. So this is forward biased only, and your output, this is short, right? And your output is same, your output is same like your input. That's why it is following that. You write down your ID. And what is the meaning of your name? Matlab શું છે
Yes,
તારું?
I knew, but I forgot.
But anyway, you don't forget analog. That is good. Okay, so I hope everybody has understood that. And then on the same line, anybody would like to try this and leave the ID? See, here it is minus, plus, and then plus and minus. So this is not additive. But let's say you consider this as an ideal diode.
Ma'am, when the input voltage is less than 5 volt, the 5 volt.
Take me. An ideal diode mano. Okay, you start that.
Yes.
This is an ideal diode, and your homework will be you take this as 0.7. That will be your homework, right? Tell me for ideal diode.
Ma'am, here in forward condition, this diode will be in 1 second.
See, this is negative and this is positive. See, when this is reverse bias, let's say, then this whole segment is not, it is like not there. Okay. Only when it is forward bias, that plus 5 volt will come into this thing. So,
Ma'am, I was saying when it will be in forward bias, this will be short circuited, so 5 volt will be
when it is forward bias, this is minus and this is plus. Okay. And this is 5 volt. Now see, આનું જે plus છે એ 5 volt છે and this is minus. So when will this be forward biased, let's say? When this is less than, for all the voltages which is less than 5 volt, right? 5 volt છે ને અહીંયા. First you should be clear what is forward bias and what is reverse biased. Ideal diode share. Here, if this 5 volt would not have been there, then when this is positive, even 0.1 volt for an ideal diode, a positive hoy આનાથી, કે આ વધારે હોય, આ plus છે, એટલે 0.1 પણ વધારે હોય, in case of ideal diode. If the difference is even 0.1, this is more, it will be conducting. In case of non-ideal diode, if this is 0.7 and this is This is 0.1 and this is 0.8, it will conduct. So this potential has to be more than this to conduct. Positive has to be higher. It is positive, it has to be higher. In case of ideal diode, even if it is here it is 0 and it is 0.1 volt, it will conduct. So this, just the difference is 0, it will start conducting. Okay. But a positive plus say 5 volt છે. Okay, a 0 નથી. Usually the connections are that way. So if it is less than 5 volt, it will conduct this side. If the is less than
Not conduct.
it will not conduct if it is 5.1. If it is 5.2, if it is 6, 7, 8, up to 12, it will not conduct. But if it is 5, if it is 4, 3, 2, 1, minus 2, it will conduct now. So everything less than 5 volt and whole negative cycle, it will conduct. Okay, na? So above 5 volt, it will, above 5 volt. So that is, let's say 5 volt is here and then here also. So above 5 volt, it will conduct or not conduct?
Not
Saneke?
conduct.
Not conduct.
Not
conduct.
conduct. Above 5 volt, it is what? Reverse biased, and it is not going to conduct. Not to conduct means this segment is not there, and hence this is open, and hence no current is flowing through R. Remember? And there is no drop here, and when you use KVL, whatever is at your input from 5 volt to 12 volt, and again 5 volt will appear at the output. Okay, so your output is like this way. Then, so you understood. So this is, it is following. We did up to this one. It is following. Okay, આટલું કર્યું આપણે. Now, when it was less than 5 volt, this was
Forward bias.
less than 5 volt. What was there? It was not conducting. So the output potential is as રહેશે ને constant. 5 volt to change.
Yes, ma'am.
Okay, so this 5 volt will remain for the, and then when it is not conducting, sorry, what was here?
No, but less than
For
5
about
volt,
5 volt.
the diode will be
Greater
conducting.
than 5 volt to 12 volt, it is not conducting, and I is 0, your input, your output is following the input using KVL. For less than 5 volt, it is 4.8, 4, 3, 2, 1, minus 1, it is conducting. હે ને? પણ ideal diode છે એટલે voltage drop શું છે? 0 છે. So for all the voltages less than 5, તો આ બધું less than 5 છે. So it is 5 volt because there is a battery here. If 5 voltage રહેશે. So for all the voltages less than this, it will is conducting, and because it is ideal diode, the port voltage drop is 0, and that's why it is constant 5 volt at the output. Okay. So all this constant voltage is when the diode is conducting, and this is when it is not conducting. Nothing to be confused. It is really simple. You just understand KVL when the diode is conducting and a conductor to hoy. When it is conducting, it is just this point and this point is shorted. So this point is shorted with, I mean, this point is 5 volt then. Okay, this is 0. And this. Okay, so let me, the time is up already. So, okay, before we end, I want to discuss that. Can I take your extra lecture at 6 o'clock? Because I missed one lecture, no? તમે લોકો free છો કે નથી? તમે પછી saturated હશો. I don't mind.
And today we are having actually
Yeah.
already one lecture is scheduled at 6 to 7. 5 to 7 we have extra lecture.
Okay, how about tomorrow 8:30? કાલે 8:30 માં લઈએ, 1 કલાક લઈશ એવું હોય તો.
Yes, tomorrow it is fine for me.
Yeah, hello.
Well, tomorrow in
Any-
morning,
You have lecture as per your timetable?
No.
हाँ,
Today we are free.
हाँ,
Today we are free, ma'am. Today we are free after 5 p.m.
Eh?
Today we are free. Today we are free. Today we are free.
No, somebody said no, you have some lab.
No.
Yes.
That is tomorrow. That 5 to 7 lab is tomorrow.
Okay. See, today give me 1 hour, and if from 5 o'clock, 5:30 to 6:30, rakh de.
Ma'am, tomorrow 8:30 would be fine. Like today we are having lab and 3 lectures. So, ma'am. In morning 8:30.
Tomorrow there will be only one lecture in the morning.
Yes,
Ma'am, tomorrow
there is second
morning
lecture. First
8:30.
lecture we are free.
Tomorrow morning we can have lecture.
ma'am, tomorrow morning
Kal
8:30.
super.
We
Okay,
have a
tomorrow
class.
morning 8:30. 8:30 को class है.
I'm in computer science, minor in computer science.
No
उनका class.
problem. So then today 5:30 से 6:30 रखे.
हाँ ma'am.
You have to listen only.
But-
ना. I'll teach you. हाँ.
या तो कल 12 बजे रख सकते हैं.
Yes, ma'am.
If
Tomorrow
possible,
12.
Tomorrow 12
See what
o'clock is
happens,
fine.
either I'm traveling to the institute, so 8:30 I finish now, then I can go to the institute, I'll have other work now, then I don't want to cancel. That's why I'm telling you that definitely I should also be available now. That's why. Tomorrow
But-
12, I may be occupied, and then I'll have to say, oh, something. No. So I don't know tomorrow because there may be some meeting and I don't want to say no. That's why. But today 5:30 to 6:30, any problem?
Today actually we have classes from 8:30 to 5, so it becomes very hectic to concentrate.
Ah,
after that.
definitely. Okay. ठीक है तो कल 12 बजे 12 o'clock you said, right?
Yes, ma'am.
Yes, ma'am.
हाँ तो 12 to 1 we keep it. ठीक है? No problem. 12 to
Ma'am,
1. हाँ बोल भाई.
it was a little request about that lab book, that if you can do something about the graphs and all.
Maybe what do you mean?
Yes.
I can do means what do you mean? See how the
Because-
lab is, you have to do it in the hardware, okay? This lab you have to do it in the hardware and you have to plot the graph in the lab book. Now what do you want me to do in this?
No, it will be very difficult to make so many graphs accurately.
Because these graphs are
in the-
very
What is
accurate in
difficult?
the-
What is difficult for you guys? X-axis draw kari, Y-axis kari. You draw the graph, diode graph with the scale 10, 20, 30 milli, some approximate. It is not that you have to be precise up to 2, 3 decimal. What is tough in that?
All these circuits and graphs will already we are
No
getting.
circuit. See, circuit is there in your lab. You just draw the graph as whatever is as C. You change R, then you will get something else, right? So you can, if y-axis is your current, then for some you draw 10 to 100 milliamp or whatever, and then approximately you draw the graph. What is big deal in that? I can teach you tomorrow 12 o'clock.
No, ma'am, but drawing there are many per question there are more than 2 graphs and there are 6 questions. So that
For
sum up
drawing
to.
2 graph from whatever you are getting in LT Spice doesn't take more than for 1 graph.
No, ma'am, but there are.
For 1 graph, it takes 1 minute. For 2 graph, 2 minutes maximum. For 2 graph, 5 minutes it takes.
Can we put
Ma'am, there are two or minimum 2 graphs per question and there are 6 questions. So that sums up to a whole lot of graphs.
हाँ, so
And
I
we have-
take them for 2 graph. If I give you more time, also 5 minutes से ज़्यादा नहीं लगता है LT Spice में करके book में करने का. I can show you that tomorrow. I mean,
So, ma'am, in
you-
the submission only the book has to be submitted.
हाँ, बता.
Only in the submission only the book has to be submitted.
नहीं, yes, so no, what you will do, you will take this using phone na PDF scanner or whatever, and you upload it in the classroom. I will send that request.
Ma'am, but we are plotting the circuit in the IT Spice, and we are plotting the graph there only, and then we just need to copy that graph in our notebook. So instead, we could just submit the
See, whatever
screenshot.
you are telling, do you think I have to learn this and I don't know? If I'm telling you to do this way, you do it. It is in your interest. Otherwise, you will only suffer. And I don't have to explain you the consequences of this.
No, ma'am, we are only saying that it will be efficient. No, I mean, LT space graph will be efficient, and we just have to copy the graph in notebook. So
That's what I'm telling. Whatever you are telling, do you think we don't know? I don't know. What is efficient in that? It may happen that the whole class will fail one day. I don't want to do that. In previous submissions, I had up to 7-8 decimals, same answer. Now, even if anybody can come under benefit of doubt. I don't want to do, I cannot go and see 350 students. And drawing a graph, as I said, for one graph takes 1 minute, I'll give you 5 minutes. Drawing a graph, if you're finding challenging, I think you should practice now. Because this is the base. If you're finding drawing a graph challenging, I think you should definitely now draw only and practice it. What is big deal in that? And there is no point of argument. If you're not ready, tomorrow you may have to come to the institute also and you will have to submit the graph book. Now, okay, you may be doing everything fine. I have to look to all 350 students and see and make decisions. And this lab component is very important. And at the last, we will take the Viva and the continuous evaluation on your lab book. Now, you will guarantee me that all 350 are doing? You may not know name of many of your colleagues also. So soft thing means easily copyable, first thing. And drawing graph, I know how much time it takes. And that is the practice that has to be done. These days you are working from home. If you are not ready to do or put little effort also and need everything, just copy paste, it cannot work that way. If you are finding challenging to draw 2-3 minutes of graph, please do it. Because tomorrow you may have to, face more challenging things when you are working. You cannot just draw back because of little things every now and then. Is that making sense to you? And documentation is very important wherever you go.
Ma'am, can I say something?
Please say, no problem. See, tell you, I have got before answers with 6-7 same decimal 6-7 decimal digits. Now you tell me whom should I fail and whom should I pass? It is difficult for me to decide. In that case, whole batch will be suffering. I don't want to do that and give 0. Because here, how will I know who has copied from whom, first of all?
मैम लेकिन मतलब नोट में ही तो ज्यादा कॉपी होगी ना, वो एलटी स्पेस में तो स्क्रीन से भी बता सकते हैं कि किस मतलब इसने अपने खुद की
एटलीस्ट उसने परफॉर्म किया है कि एटलीस्ट उसने परफॉर्म किया है.
X has not done anything and has got everything from Y. How will you know that?
मैम स्क्रीनशॉट है तो फिर सबके लैपटॉप के अलग-अलग स्क्रीनशॉट होंगे ना, तो
फिर what I'm telling that वो सेम आते हैं तो फिर क्या करें हम?
मैम तो नोटबुक में तो कॉपी ही कर लेते हैं ना डायरेक्टली, नोटबुक में कॉपी कर.
No, but instead of teaching I'll have to do another business who has copied from whom, right?
No ma'am, we can do that in lab. The TS can tell us to share screen.
हाँ
हम टीएस चेक करते हैं, मतलब स्क्रीन शेयर करवा के परफॉर्म करते.
नहीं, somebody has copied. Now you also don't know your friend has copied from you. Then how we will know who has copied from whom?
तो मैम टीए अगर 2-3 क्वेश्चन पूछ ले तो जो जिसने कॉपी किया है वो पकड़ा जाएगा ना, उसको कुछ नहीं आएगा.
नहीं, so TA will make sure every now and then that you have copied or not. So we are here to teach you and have a positive environment or run behind whether you have copied or not.
कॉपी वाला इशू तो दोनों में रहेगा ही ना, एसएस में वहां पे मतलब
ऐसे रहेगा. If you are doing with your writing in your notebook, how will somebody will take your notebook and start writing?
वो तो मैम किसी भी के नोटबुक से डायरेक्ट ग्राफ दौड़ सकते हैं
PDF
ना।
से कॉपी कर ही सकते हैं ना वो लोग। ठीक है तो फिर
That you do na while you are drawing also. If you are copying, see, you are that dumb that you are copying. Okay, I accept that somebody is that dumb that is copying from the friend. If you are arguing so much, if you are that dumb, you should draw, not once, twice, because drawing also is a learning. If you don't know, but when you draw, you will learn. Okay, so this copy pasting is closing eyes and doing. But if you are copying and drawing with your hand and pen, you are doing some action. It is a process of learning at the same time. So without any further argument, I am not going to answer you all these things. If you, and then drawing is not, I'm not telling you to draw the map of Taj Mahal. Okay, or something challenging. It doesn't take more than 2-3 minutes. If it is taking, practice it. And make sure you don't take more than 2 minutes to draw a graph from LT Spice. Okay, so just knowing these are the things that will help you to grow. And if you argue tomorrow with your boss this way, he will understand where are you standing. If somebody is telling you something, right, we are not stupid here. It is all in your interest only. And tomorrow you may have to come to the institute. Then what? फटाफट क्या soft copy निकालोगे? So some pages you will give me and some full scape. So how are we going to manage your things? If you come down tomorrow, how will you submit me?
मैम सॉरी लेकिन अगर आपको मतलब कॉपी कम करनी है तो फिर एक मतलब LT स्पेस में हम लोग टेक्स्ट में हमारा नाम लिख देंगे ना एसएस लेते समय।
Pardon?
हाँ वो कमेंट ऐड कर देंगे बॉक्स में, वो लेबल करते हैं नोट वैसे नेम,
या तो रजिस्टर का नाम ही हम हमारा लिख देंगे।
No, tomorrow if you come to the institute and you are doing a hardware lab, then you will start doing now hardware lab if you are coming to the institute. Then how you will do? See, this is in hardware, you get in the oscilloscope using power sources, you will see the reading and you will plot.
मैम तब तो ऑप्शन नहीं रहेगा ना, और मैम अभी वर्कलोड भी ज्यादा है, मतलब सारे सब्जेक्ट के एक लैब है पर वीकेंड।
No, forget option नहीं रहेगा. How you will do? Even if you have an option, how will you do your hardware lab? How will you plot IV? Even if you have an option, all options are available. Tell me the best thing कि हार्डवेयर में कर रहे हो तो IV कैसे करोगे?
बट मैम कॉलेज अभी चालू हुई तो भी हम कैसे करेंगे? क्योंकि हमारा एक भी लैब ऑफलाइन ऑनलाइन, अब सभी लैब हमारा ऑनलाइन सॉफ्टवेयर के थ्रू हुआ है अब तक के।
That's what I'm telling you. So tomorrow if you come, कल आना पड़ेगा शायद, ठीक है? That you know. It is not that you will do everything from home. You may come down. Schools have started, and it will not be a surprise if you come down. Then what?
मैम ऑफलाइन में हमें फिर भी कुछ पता नहीं होगा कैसे करना है, तो वो तो सब हमें वैसे सॉफ्टवेयर के थ्रू ही करना पड़ेगा।
So that is you are deciding कैसे करना पड़ेगा. You will have to come to the hardware and do. ये हमारा नहीं चलता है. You have to come to the hardware and do in the lab. So if you are coming to the lab, how will you do? तुम अगर लैब में आते हो तो कैसे करोगे? अरे जल्दी बोलो. I have something else to do now. If you are coming to the hardware and performing, then how will you do? Tell me fast. So where are you all? You were just telling me now something. Where are you all? Tell me. You tell me how to do best thing. I don't want to burden myself, nor you, nor TS.
मैम हार्डवेयर में होंगे तब तो फिर मतलब ग्राफ हमें खुद से ही बनाने पड़ेंगे, बट अभी LT स्पाइस के डिक्टो कॉपी करने में से
तो खुद से बनाने पड़ेंगे. So then how you will submit me when you make your
नोट? मैम वी आर सेइंग कि मतलब नोटबुक में हैंड रिटन कैलकुलेशन तो करते हैं, बट ग्राफ LT स्पाइस के डिक्टो कॉपी करके फिर
approximate is fine ना. Ditto means I don't want LT spice thing to be you copy.
बट वो साइन वेव और वो सब बनाने में टाइम लगता है, तो मैम बस वी आर सेइंग कि सिर्फ ग्राफ के एसएस डाल देंगे, कैलकुलेशन तो हम करने ही वाले हैं ना.
But when you come, let's say in your 4th lab or 5th lab, when you are doing in the college, how will you submit me that?
मैम तब सिर्फ जो कैलकुलेशन है सिर्फ वहां पे कैलकुलेशन तो हमारे पास नोटबुक में रहेगी ही ना पुराने लैब्स की, सिर्फ ग्राफ नहीं होंगे।
नहीं ग्राफ नहीं होंगे तो what I will do with your submission without graph? Your submission means graph first and then with equations. So when you are submitting to me, otherwise you will not get marks. Okay, up to you. If you don't submit anything, you will get 0. So
बट
this is not
कॉलेज ऑनलाइन है तब तक तो पीडीएफ कंसीडर होगी ना, मतलब अभी के लिए पीडीएफ सबमिट हो रही है तो फिर
I will, so half you will give me soft copy and half I will take hard copy.
तो हाफ
Then how
ऑनलाइन है
are
हाफ
we
ऑफलाइन है तो
going
फिर वैसे ही होगा ना।
You have to give a
Sorry.
single book. Okay, if you want to do, those who want to do can do, those who don't want to do, you will only get full marks if you draw all of this thing. And if you don't know how to draw the graph from LT Spice, I will teach you tomorrow in my lecture. And you should not take more than 3 to 4 minutes maximum graph. That I'll teach you tomorrow. If you want to do. If you don't want to do, don't do. It is up to you. But you will only get full marks if you do the way we have asked you. Okay, rest is up to you. If you are finding challenging to draw a simple graph, nobody can help you. Okay, so we cannot do anything else. We have to look to the whole class and make sure that a good student gets rewarded, who is working hard, who is doing things properly. And we have to filter that. We cannot motivate copying or any other ways of, messed way. It cannot be a messy thing. It has to be in a neat, clean, straightforward way. If you want to do good, otherwise up to you. Thank you.